Good afternoon, everybody. So today we are doing this chemical kinetics. Before moving on, I want to talk about this your preparation, because my results sort of this year is again all right. I don't have like district first this time. Because this time for 2023 I found these only few students because we had this COVID and my name was not that published in Ratnapura at that time, so I got this like from mouth to mouth. Some students came to me, that's all for 2023. Anyway, starting from district 6, then 13, then I guess 15, 23, 39, 40, some sort of like 61, 71, so on. Students are there. But any of these are not happy with their results. Even this 23 student, 23rd student from Ratnapura, she's having 2 A's and 1 B. Can you believe that? Even this 6th girl, she wanted to be like, either 1 or 2. She became the 6th. That's what she's saying. And from Colombo, I said that this one of girl from Sirimavo, she got 50 out of 54 chemistry. Then I thought she would do better. She was again like, this island 41 or so, I guess. Sorry, Colombo district 41 also. She couldn't even get closer to this very first, but she has 3 years. Luckily, she has 3 years. And another condition is there is this boy, he's from Ananda. His mom told me like, Madam Matameyata is chemistry. He just want to have 3 S classes to admit to any of these private institutions because he doesn't work enough. So he got C pass for chemistry, other 2 fail. So this is the situation. There is another girl. That's actually impressive. She's Muslim. She hadn't gone to school and she hadn't gone to any other classes. She got B, C, C. I wasn't expecting these good results from her. B is for chemistry, but she was thinking like she could reach these like A, B, B. She can go to these, whatever the medical faculty she is expecting, but still she couldn't. What is the reason that they all said they were expecting more, but they couldn't do that? What is the reason, Manu? Why you think? What would you think? Because nobody has done as the way they have done chemistry. They were not doing other 2 enough. That is my concern. Today, actually, a couple of these early, like, the previous students are calling each week, each year we are having still good communication. So they were like, ma'am, just calling to ask what is your results this year and so on. Then I asked them, any advice from them to these new kids? Then they said, ask them to hang in with chemistry, don't lose that, and give the same sort of effort, same sort of inspiration for other 2 subjects. How come all these students, please, like, have some sort of a results for chemistry, but other 2 are less than that? What is the reason? Manu, tell me. Are you guys understanding this? Are you going to do the same? Or are you going to do better? Manu, are you okay with other 2 subjects? I'm keep asking this how many times, even from these kids, I was keep asking. One of these kid was like, she has ran, she got A and 2 Bs, expecting 3 Bs. Her ranking is 130, 144, 144. So not even a dream to go to these medical faculties. Then she wasn't speaking. I just heard that she rang, then I on the phone. Then after a certain time, her dad was like, Madam, may do under phone. Yeah, because they were not happy with other 2. Like, that's not enough to go to these medical faculties. Then they want my advisors again for second shy. What do they do now? Everything that I am telling you guys, I was telling to them, but now they are in that situation. I don't worry about my results are good, and I don't worry about who's passing and who's entering or who's securing their positions in these medical engineering faculties. I'm always worrying about students who couldn't get there. And I don't want this to happen to you. Is that clear? Just do everything like bella kadagana vada karanda. Like for all these 3 subjects, it's just thinking like that somebody is chasing you to kill you. What would you do? You would run to your top speed. Just work like that, work like hell if you want to get through with this. Even parents are asking, what happened to my kid? What do we do now? Can you evaluate my kid? That's so like absurd to me. How do I evaluate? Like I'm only doing chemistry. So they are asking, they were not studying enough. That is the only reason. Most probably, all these are first try kids. So most probably, I think they have done less questions. It's not I'm doing lots of questions. It's not I'm doing more questions. I'm doing exact amount of questions that you guys need to fill the class. Other people are not doing enough questions. So their class is not filling enough. This is A, this is B, maybe this is C. One of these boy is A, B, C. Even from Ratnapura, his ranking is 134. Now he wants to come to meet me to have the relief. Now I would tell him, why are engineering he wants to tell me that. Then I need to do a research from I asked this from this girl Karamini and like just to analyze everything and tell me whether it's possible for him to go to this engineering faculty. She said there is this possibility, but not sure. Like on the fence kind of a thing. Why be like this? And why be like this? How tragic this? How tragic this? I'm keep asking you guys these questions because I want to improve all these 3 subjects. If you feel like still not comfortable, just find somebody you have 5 more months to go. Let's say that they are charging you 100,000 rupees per month. I don't know, even an individual, but just 500,000 rupees, that's more than enough rather failing. Understood? That is more than enough rather you are going to a second shy or being this distressed. Like these parents are saying, then I was like, then ඉතින් මොකද්ද කරන්නේ? අනේ මඩ මොනවා කරන්නද අපිට වෙන option එකක් නෑ ඉතින් second shy යනවා. These kids being like thinking like they were really talented. These kids who were thinking really talented, doing the more harm to them because they were not doing anything after advanced level exam. They think they done everything nicely, so they are not even looking at these books. But the kids who were thinking, Mama, I would least like refresh my knowledge, they were in little good situation. They knew their condition, so they are practicing. Understood? Make sure, don't promise to me, this is not my future, this is your future. To go to your future, make sure you are doing everything really, really nicely, that you are not regretting after your A-levels. Okay, make sure that. The marva worried about them, some a feeling වැඩි වෙනවා. You guys know that every year මම මේක ඔක්කොම කියනවානේ. Last year මම ඔයාලට මේක කිව්වා. දැන් 2022 results ආපුවල මම ඔයාලට කිව්වා මේමයි ආපු අය සතුටුයි, but ආපු අය හරිම distress and I don't want anybody to go to that situation. But 23 වල දැන් because of their problem, because of their faults. Okay. So I'm emphasizing, don't let this happen to you. And this is the gift I given to this thing. All right, moving on to chemical kinetics. Okay, so have the determination doing the maximum that you guys are not making me regret, okay? As a teacher, if students are not having enough good future, I don't know what other teachers would think. But happy when let's say I have 100 students, out of them 95 got through with exam, but who's gonna get the responsibility of the 5 students? They have to suffer throughout their whole life. That may be you. Don't let this happen. Stop nibbling. This is not something you're supposed to be stressed. This is something you're supposed to have the energy. You definitely do this. Would never go to a second shy. Okay. So we did up to question number 25, I guess. So today we are starting question number 26. Now come back, now relax. You three are really okay. I'm not worrying about you three, but still, a couple of these students are like, you remember that I said ladies college, another student? I don't know what she said me. She said she had 50 out of 50, but she got BCC. She got B pass for chemistry. Anyhow, they are not doing enough. Okay. So 1 gram of uniformly powdered calcium carbonate, concentration is also given, molar mass is also given, is mixing with 0.2 moles of HCl solution. So then they were collecting carbon dioxide against time, so that this is the carbon dioxide volume. So with time, this is that you can see per first minute 125, second minute it's less than that 50, third minute is less than that, that's 25 cubic centimeter were collected. That's obviously you can see this gap is getting down. And also when it is closer to 225, that you can see this is a straight line. So at which minute? 5th minute or 6th minute? Which minute? 6th minute, this sort of getting constant. And the constant volume is 225. According to the graph, the rate of at which CO2 gas is liberated decreases with time. Yeah, each time this is decreasing. Same time, but this is decreasing. This is decreasing. So that's true. Okay, B and C, B and D, I'm going to get together. B says approximately 6 minutes after starting the reaction, that's here, an equilibrium is reached. Okay, so this is just reaction they are showing only to this direction, the forward direction, formation of CO2. So they were not talking anything about this backward reaction. Yeah, that's true. Carbon dioxide concentration is constant, but they were not given any hint for the backward reaction. So can you say that B is correct? No. If A is correct, C is supposed to be incorrect. Then if you go with D, 6 minutes after starting the reaction, 6 minutes after start reaction, the concentration of different species present in the solution become constant. Obviously, see, carbon dioxide concentration is constant. What is the reason for that? Limiting factor. Something is using up. Okay, tell me, what is your answer? Oh, are you okay now? Okay, never go with hints with exact evidence. They were not given exact evidence here. Okay, so question number 26, AD correct, answer 4. Hello? Again. Again. Okay. Oh. ඔය ළමයි නිකන් මෙච්චර අමුතුරු මැද්දේ. ඒක විඩාචිසට පණිවිඩයක් තියන්න එයාගේ ගෲප් එකකට තියන්න ලියන්න කියලා. මම ලිව්වා කියලා මම ලිව්වා ගෲප් එකට. සර්ටත් මෙසේජ් එකක් දීලා කියන්නේ මැඩම් ලිව්වයි කිව්වා. හදලා තියෙන්නේ. මංජුලගෙන් ගන්න ඕනේ මගෙන් ගත්තා. ඕකේ. මම ක්ලාස් එකේ ඉන්නයි. කෝල් එකක් දෙන්න උනාට. My assistant is Mara. Now she is asking whether there is class. Class is around 2, I guess. Did you guys know that October is full of rain? Yeah. Avisavela was like, you know, tragic something. How is your home learning? So you are living in a highland, I guess. Makele. So your area is okay. Oh, really? It's very windy. Even yesterday here with the wind is Pute, don't you feel that? The wind is like you feel like me gidrakka. I don't know, like the takran sounds are everywhere, like it's gone. Oh my goodness. Okay. Just if you guys need some sort of a support, I don't know whether I'll be able to support you, but I have good contacts and I have some people to support. Just text me if you guys need any sort of support. Okay? Until you do this exam, you guys have to feel really, really relaxed. Okay, question number 27. The reaction. You have 2 NO and 2 H2, 1 N2 and 2 H2O. And they say, with respect to NO gas, it's second order. Regardless the order, reactants react according to their stoichiometric ratio and concentration. See, so that this is an extra data. So they are saying, with respect to hydrogen first order, under certain conditions, 1 mole of NO gas, 1 mole of H2 is reacting. Rate of nitrogen formation is 0.02. This is 0.02. Then the ratio here equals 1:2, 1:2. So that this is 0.02, this is supposed to be 0.04. And the ratio here is 1:1:1 for these three. Okay. If this is the amount of spending you making, so amount of spending of these two supposed to be exactly same. So that the rate of reaction of NO gas is this 0.04. H2 gas is 0.04. Other two are wrong. Question number 27, we see correct answer 2. It's supposed to be 1:2. Okay. Manoj, so you work here really perfectly, but when you are doing other two subjects, you have the same talents. So you are maintaining the same sort of like you can write almost all these answers. Physics? Physics, okay. Why are you having issues? Memory? That everybody is complaining. Everybody is complaining. You guys can talk to, I think she would support you. She's a really good teacher. Savi's mom. Just ask Savi, it's okay to talk to her mom for a second and get this some sort of advice, asking your questions. She has good hints. Just do that, okay? Regardless your own bio teachers. Okay, Savi, I guess your mom would willing to support students. I know she is a good person. Question number 28. Under a given set of conditions, a catalyst increases the amount of product obtained in unit time. Yeah, that's true. That is called the rate. When it decreases activation energy, so that rate is increasing, but no change of percentage yield. A catalyst alters the enthalpy, never. Only the activation energy. Question number 28, answer 3. Question number 29. Consider the following statements regarding kinetics of chemical reactions. The unit of rate is independent of overall order, that's true. But where is this rate unit? Time unit. So rate supposed to be concentration divided by time, either moles per cubic decimeter per second or Pascal per second. this does not change by order of the reaction, that's true. But rate constant, K units depend on order. So A incorrect. Increase in the temperature, increase the rate of exothermic, B incorrect. Increase in the concentration of reactant does not affect the overall order. Yeah, order can be changed by changing mechanism only by catalyst. Usually when you increase temperature by 10 degrees Celsius, rate doubles. Question number 29, only C correct, answer 3. Question number 30. Consider the following elementary reaction. Elementary, you can just write the rate expression. Rate constant T, temperature T, rate constant A, K, A's number of mole N, B number of moles N, volume V, rate R, rate of reaction at time T is Q, pressure P. They are asking at that time pressure P. This expression for pressure P. Could you get the answer too? Tell me, what is your answer? You didn't do because it was difficult. Well done, Mano. See, Baba. Okay. The hint is they are giving this information to go with PV equals nRT. Could you understand that? So from this equation, you can get pressure. So R given, T given, and V given. So we just need to calculate number of moles. For that, we have to go through this rate equation. Understood? So the given reaction is elementary reaction. So the stoichiometric coefficient equals order. So that we can write the rate expression as this. Clear? Then, knowing total number of moles here, so we can calculate P because they were given V, R, and T. For that, we can use equilibrium conditions. How many times you have done such questions? To find the total number of moles, you have to go through the equilibrium equation. This is just a normal, like if they have given this as an essay question with data for, numerical data for these terms, then you can calculate this very easily, knowing the numerical values. I guess it's harder because they were given these symbols. Anyway, so I'm gonna go like this. So A, B, C, initial number of moles. Let's say the dissociation is X. So remaining is N minus X, N minus X. Cx is making volume V so that you can find right concentration. But rate after time T equals to Q, which K, A into B, and this is A and this is B. So I'm just going to go substitute with these two. From that enemy, I am subjecting X. X is the final remaining or after the dissociation. But still, I don't know what is this X. And we do not need X. We need X to calculate total number of moles. Now, what is the total number of moles? Oops. Total number of moles here is total number of moles here equals n minus x plus n minus x plus x. Okay, this one I'm playing little extra because in these answers they have q to the power half. So root q divided by k equals q to the power q divided by k to the power. Okay, so that this is my x. This is my x. I don't want x. I need the total number of moles. Then total number of moles equals this. This. Totally 2n minus x. Then I have x in terms of other known stuff. In terms of all the other known stuff. N known, B known, Q known, K known. So I am substituting total number of moles 2n and this minus, and then instead of this x, I'm writing this thingy. Okay, if I simplify this, multiplying by n, I can come up here. Then to this equation, only unknown is n. So instead of this n, I'm substituting this whole thingy. Rearrange, then you can get the answer. We did this kind of questions, but the thing is, I guess you have forgotten equilibrium. This is not equilibrium, that's what happened. But see, a harder equilibrium now connecting to easy chemical kinetics. So, sorry, I don't know whether you have taken the answer, but if you have taken the answer, well done. Okay, the Sinhala thing I have written here, since elementary reaction, stoichiometric coefficient equals order. Since elementary reaction, stoichiometric coefficient equals order. Then we can write, this is initial rate. Initial rate equals to this. But they say rate after time t, which equals to q. So we are substituting later to q. Sorry, could you get this answer? No, you done? The next side. But in the given expression, x is not there, but also we need the total number of moles. I don't like that. In a way, sort of all right, because you guys are not going with this equilibrium. I was sort of thinking to send this recording to Ratnapura and get Ratnapura recording to you, but this week there is no class for Ratnapura students. Okay, last part. Then we finish. Question number 31. Constant temperature, double the concentration of all the reactants in the elementary reaction, increases the rate by a factor of 8. They say this is an elementary. If it's an elementary, that's true. You can just do a little calculation and show that, like initial concentrations are X and X for A and B. And the second time concentration not 2X and 2X. If you divide R1 by R2, so the connection is 8. So this is complementary reaction. The order with respect to a reactant is equal to its stoichiometric coefficient. Yeah, that's why we can write this is the second order and this is the first order. That's why we could go through this sort of a calculation. So it explains the first one. Because when order become third, when concentration was, when if order is 3, when concentration doubles, it will become increasing by 8 folds. That explanation is sort of there. Who could get the answer 1? One, got? What is it? What are you thinking? The connection. Second one is true or to get the answer as 1. So you get answer 2. You put a 1, but not that sure. Yeah, are you okay now? Yeah. It is like this, Papa. There are some questions, only that some sort of intuition of that lecturer who has done the question. But since they are in the same board and they are still in the same papers, this is 2013, this new syllabus, so you cannot forget this. Then just memorize that. If this sort of situation is there, then you're going to get as the answer explains, the answer is supposed to be 1. There is no other way. Just try to understand his brain, his thinking style, and get practice with that. Otherwise, we cannot write any of these. Rather, even if they say elementary, we are writing with stoichiometric ratios. That because elementary order equals to stoichiometric ratio. So A is explaining. Okay, 32. A gas A dissociates at temperature T, and this elementary reaction they are using, A goes to 2B plus C. N moles of A were kept in rigid container and allowed to dissociate at temperature T. Initial pressure is P naught. After T time, pressure is P. That is, the final pressure is P. Rate of reaction at time T with respect of pressure is asking. So this is an elementary reaction. Order equals to stoichiometric ratio. And that we know when other parameters are constant, pressure is proportional to number of moles. So I'm going to do everything that usually I'm doing to number of moles, pressure instead of number of moles, considering number of moles as pressure. So initial number of moles is P naught. Initial pressure is P naught. final number of moles or pressure is Pt. Then the difference is the difference supposed to be which is making C, that is P naught minus Pt. But here you have choice of that, so that 2 into P naught minus Pt, which equals 2 P naught minus 2 Pt. So after time t, I'm taking this pressure as Pt because I need the total pressure as well. Later, I'm going to say that Pt equals to P, final pressure. Then, according to Dalton's law, if we go with the total pressure, that equals Pt mean A, 2 P naught minus 2 Pt mean B, P naught minus Pt is C. So that total pressure equals this. From that, I can subject Pt, which equals 3P naught minus Pt divided by 2. So that Pt mean partial pressure of A. That is, after time t, partial pressure of A or Pa equals to this Pt, which equals 3P naught minus Pt divided by 2. But here we have written the rate law, the initial reactant is only A. So we can write R equals K into concentration of A. Now, instead of concentration of A, we can write partial pressure of A, that is Pt. But Pt equals to this. Then just do the simplification. K prime into 3P naught minus Pt divided by 2. This 2 I'm going to get here. So K prime divided by 2 totally is a constant. So I can say so that R is proportional to this thingy. If this K1 divided by 2 equals to constant. So that's this. But the total pressure they were taken as P. Total pressure is P. So this is the answer. That's again going with equilibrium. So question number 32, answer 3. Again, I have written since elementary, order equals to stoichiometry. There is this style when you go with a couple of these questions, and especially when you're going with equilibrium questions, you're really going to be all right. If you feel like these are harder, that's because you have forgotten equilibrium. But don't worry, I'm making it like, I don't want to soothe you guys so much. I think sometimes why these students are not doing enough. And they think when I'm making them confident, they would think, we are doing better. It's not you guys are doing better. It's I'm asking you guys to do better. Sabi, I'm going to these kids in here with their speed. They are done, so I'm moving on. Let me know if you want more time. Question number 33. The rate of an elementary reaction increases with increasing concentration of reactants. Concentration twice. If it is first order rate doubles, second order rate 4 times, third order rate 8 times. That is there. As a general statement, that's true. The rate of an elementary reaction is always linearly. No. To be linear, if you draw with respect to first order, that's linear. If it is second order, this is supposed to be a squared, then linear. Third order, a to the power 3, it's then linear. Clear that? So 33, answer 3. Anything? Question number 34. In all catalyst process, adsorption is very important. No, not always. Catalyst supposed to be solid and reactant supposed to be gases. So that's heterogeneous catalytic condition. Let's say the catalyst is gas. How does it absorb? That's not true. Adsorbed molecules are highly reactive. Yeah, because then the collision of the other molecules onto them is becoming easier. So that question number 34, answer 4. Yeah, I'm in a class, but that's all right. I'll ask Suji to give it to you. Just yeah, ring the bell or just ring me once you're here. Okay. Question number 35. The reaction between H2 gas and Cl2 gas is catalyzed by palladium. Yeah. Which one of the following is most appropriate? Palladium acting as the catalyst doesn't change enthalpy. Both hydrogen and chlorine adsorb onto palladium. That is the correct answer. 35. Suji, answer 5. 35, answer 5. Suji. Question number 36. The rate of a chemical reaction increases when the concentration of reactant are increased at constant temperature. The only reason the number of collisions between molecules increases, these three are little like Suji, are that's a letter එකක් දුන්න නේද ශෂීරෝණට දෙන්න කියලා. තියනවද ඒක? දැන් යාවම මේක දෙන්න. මට මේක ගෙනල්ලා පෙන්නන්න ඒක. That's us, Aya's daughter that who became 23rd of Ireland in her year. She's little old now. She's in her 30s, I guess. The fraction of molecules with energy in excess of the activation energy increases. Fraction, you cannot say that's true because fraction goes like x divided by n is a fraction. But if you increase number of molecules, then number of molecules exceeding activation energy is also proportionately increasing. If you have the total number of molecules 2n, then this is become 2x. That's again n over x. So you cannot say that's fraction, but the amount is different. If you go with number of molecules, you can draw 2 graphs. But if you go with fraction, for both n and 2n, you are drawing one single graph. Remember that? Okay. Energy of collision increases as long as the temperature is constant, and this is constant. Fraction of collisions with correct, that's again the same explanation. B and D, same explanation. Question number 36, only A correct, answer 5. ඒ මොන හරි බොන්න ඕනිද කියලා අහලා දෙන්න. හරිද? ඕනේ වටිය බෑ. ගේට් එක ගන්න ගිහලා ඔක දීලා එන්න. මේ අපේ මෙහෙන්නකෝ. මේ ඔයාලා දන්නවද සුජිට මොකද වෙලා තියෙන්නේ කියලා? සුජි පුංචි වෙනවා. දතක් එනවා කටේ. කට අරින්නත් ඒකයි ඔය. She really likes you. She's like, yeah, hey, Baba, maat ek mudra kata. Hey, kata kana Sujit ek. She's very innocent. Even when you say bye, it's a big thing for her. Question number 37. Two different reactions taking place at the same rate, at the same temperature, should have same activation energy. No. May or may not. Because activation energy is, activation energy can change the rate, and also the temperature does something with activation energy, increases the number of molecules exceeding activation energy, but there is no direct relationship. Activation energy is a characteristic of a certain reaction. Depends on the mechanism of the reaction. Okay. The rate of a reaction is directly proportional to, no, there are a lot of things to consider. Should we consider other factors? There are no simple relationship, or you cannot say it's inversely. A sort of inversely, not directly. Because activation energy high mean what is happening with the rate? High activation energy, low rate. Yeah, low rate. So maybe it's inversely, not directly. Question number 37, answer 5. 38. Which of the following valid regarding this catalyst? It changes enthalpy, no. Decreases the activation energy, yeah, of a chemical reaction, true. Not consumed during chemical reaction, chemically, yes. Physically, they can change. It increases both the rate of forward and reverse, yeah, of a chemical reaction, and it will be by same factor. This is not a fraction. Same factor means let's by X amount, by Y amount. That's true. Question number 38. B, C, D correct. Answer 5. Question number 39. In a chemical reaction, all molecules with energy greater than the activation energy form products. No, only with proper orientation. Otherwise, no product. They are getting again bouncing off from each other, getting away from each other. In all chemical reactions, the reactant must go through a state having energy greater than the energy of reactants. What is the state? That state is the higher energy state. That is the energy barrier. That is the activation energy. So this state is the activation energy. That's true. 39, answer 4. Sorry, 34, okay. No, that's wrong. 39. Moving to 40. Answer 1. Well done. Okay. Activation energy, they were not talking about these backward reactions or multi-step reactions or whatsoever. What do you know? It doesn't say it's in equilibrium. So only forward reaction is considering. Activation energy is the distance between reactant, and that is this, and the highest point of the curve, and that is this. So in between these two, you have delta E1, and that is only this delta E1. This is the delta E1 they were given. Question number 40, answer 1. Question number 41, answer 4. Yeah, because they say this is 50 without, with 50. So X is not a proper catalyst. Use of X will not change the reaction rate significantly. Yeah. Activation energy of step 3 can be lowered. No, it's 50. Use of X increases rate of, no, it's not doing anything because here again 50, with 50, without 50. Increasing of temperature will increase the reaction rate. Yeah, that's only with temperature, with or without X, because with kinetic energy increasing, reaction rate increasing. 41, A, D correct. Answer 4. 42. Increasing the temperature will increasing the reaction rate always. Yeah, that does always. So that statement is true. The activation energy of a reaction decreases when the temperature is increased. No reaction, no connection. Activation energy cannot affect by temperature. Only catalyst can change activation energy. It increases number of molecules which exceeding activation energy. 42, answer 3. (43) Wrong regard to the activation energy of a reaction. The activation energy of forward reaction in an exothermic is lower. Yeah, this is exo. So this is down. See, the forward less, backward greater. Length is high. EF is less than EB. What do you want with it? Okay. The activation energy of a slow reaction is high. Reaction rate is less when activation energy is high. Activation energy of a given reaction pathway is unaffected by the catalyst. Yeah, given pathway is not changing. That's again true. The higher the initial concentration of reactants, the lower the activation energy. Concentration, activation energy, no connection. The higher the initial concentration of a reaction, lower the activity, there is no connection. Okay. In multi-step reactions, reaction rate controls by the slowest step, the step with highest activation energy. 43, false asking. Sometimes you do this mistake as well. Here again, you're going to get the answer 5. Anyway, so this is supposed to be B and D. They're asking wrong questions, wrong answers. Question number 44. Most reactants take place more rapidly at high temperatures than low temperatures. Yeah, when the temperature is increasing, reaction rate is high because the kinetic energy is increasing. The correct reason is asking, the increase in temperature does not change the activation energy. Only by catalyst activation can be changed. A, incorrect. The increase in temperature decreases activation energy. Wrong. When the temperature increases, the number of collisions per unit time. What do you call number of collisions per unit time? That is the collision frequency. So collision frequency is increasing per unit volume. C, correct. The increase in temperature results in increase in the percentage of high energy collisions. Yeah. Collision number and collision percentage also increasing with high energy when you increase the temperature. When the energy is equal or higher than the activation energy, and also when collide with proper orientation, products formed by successive or effective collisions. You know this, my district 23rd person is, I said that she has 2 A's and 1 B. She was, right after the exam, she started her second shy practicing. She was worrying about so badly about this B. Even I said, even you get a B plus, you cannot be that low your ranking. Because you are safe up to your ranking become 110 also. But she was really worrying and she was practicing for the second shy as well. But anyway, they have secured their placements. Worked nicely. That was the only student from Lyceum. But I got through with this time. Anyway, at least one is there. Question number 45. With respect to stoichiometric ratios, you are always dividing by the stoichiometric value. I have written this for you practice, but they were asking only this thingy. 45, answer 4. (46) Which of the following statements are wrong regarding to order of a reaction? Order of an elementary reaction should be a whole number. Order can be fraction or negative. We did fraction 1 for, remember that this chlorine free radical, that thingy we did for theory, that one. When I'm saying something with theory, Manu, if you feel like I don't have that thingy, just ask me. I just can send you those papers so you can ask from these girls. The order of the reaction is an experimentally, yeah, you need an experiment to find order. Order of reaction is always equal to the sum of stoichiometric coefficients only for elementary. They were not talking about that thingy. That's why C is incorrect. The order of a reaction is the sum of power of the molar concentrations of reactions in rate law expression. Why you are writing a rate law expression? You're writing a rate law expression knowing that reaction is elementary. So with that, then total order equals to these two. Understood? If you've written a reaction for rate expression, whatever the orders are coming with stoichiometry. Power of molar concentrations. Clear that? So that question number 46. AC correct answer 5. So we are writing a rate expression only if we can confirm the order. Okay. So D is supposed to be correct then. 47. See, all these are like, that's what I'm saying. Luckily, you guys, you all are doing biology. Math students are really getting confused with these kind of questions. They think a physical chemistry part can get over only with calculations. Do you see any calculation here? See the physical chemistry. See last couple of questions, like starting from question number 31 to 50. No one of a single calculation, but that's the hardest part. That is the parts usually students are going wrong. But did you have term test soon? You're going to have term test soon. This time, your term test marks supposed to be high, really high, comparing to other students. Most probably they would ask up to equilibrium. I didn't do equilibrium with you, Manoj, but with them, Manoj, this is how you get this. Equilibrium tutor, I'd give that. Don't make it. Thank you, though. Uta, if you have the term test before we started equilibrium, they have their notes, you can ask them. Write to the group, somebody would answer. You're going to do these couple of questions that I have done for theory. I have done more than 100 questions for theory, I guess, more than 100. Hello? 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 Just excuse me because still these new kids are talking. So I'm just saying, Thenami, we have done lots of these equilibrium questions. You go through the note now because it's time. I'll post this revision of last year's one, okay? So we can save time. Just read that first, listen that first. That's a little rough idea, but it's giving a huge push if you have forgotten equilibrium. Then go through the note, go through the question before term test. Hello? Okay. Yeah, I'm handing it to Suji, okay? She will get to you. Okay. How does she know she's just swimming here? Okay, so make sure. Remember, usually I say other students marks are going like this, then you would feel a little frustrating because very first term test your marks are going like this. But when I'm starting this at unit 11 and unit 12, your marks are increasing this way. So reaching 100 is really easier here. That is my style. I'm not targeting here for term test. That's the difference. I never target for term test. I'm targeting only for the final exam. This is 100. I'm expecting 100 from you all. Okay. So question number 47. Are we done with 46? Yeah. 47. the rate of a reaction consisting of several steps is determined by the step of highest activation energy, because highest activation energy means reaction is slower. Second statement, at a given temperature, the rate of a reaction with the lower activation energy will always be the faster than another reaction with high activation energy. That we cannot compare rate and activation energy directly, because there are lots of factors to consider with rate. There are other factors which affect reaction rate other than activation energy: temperature, catalyst, pressure, physical state, even the radiation. There's a lot that we did everything. Question number 47, answer 5. (48) In a reaction consisting of several elementary steps, the step with the highest activation energy is the slowest step. Yeah, that is the rate determining step. Reactions with different activation energies cannot have the same energy. May or may not, who knows, that depends on different factors. So, question number 48, answer 3. Question number 48, answer 3. Question number, is it all? Yeah. Wow. You guys are good. OMG. Moving to question number 1, structured essay. Am I too speedy? I'm not too speedy. You guys are making me speed. That's totally your responsibility. Seriously. Ratnapura 24 and Colombo, not this Colombo English medium, one of these student is really good, but this Ratnapura Sinhala medium and Colombo English medium making me faster. Otherwise, I would say, let's go faster. You guys need time, but you guys are bringing me faster. Writing all these answers at home and doing everything correctly. Okay, moving on to question number 1. Following is a trend of depletion radioactivity of 10 grams of sample of element F. Half-life of the element is asking. Before that, if you go with half-life of these three, just for your practice, TF definition, the time required to reduce the initial concentration into half, 0th order is proportional to initial concentration. T half equals A naught divided by 2K. First order, again, proportional to initial concentration. T half equals 0.693 divided by K. Second order is inversely proportional to A naught. Clear that, initial concentration. If you move on to the question, see, lost the annotation. Each time, so if you calculate this time, always the time gap is 5,600 years. Same time gap here. Same time gap here. This gap is still same. So same gap. And if you go with the amount here, amount become half here, then again half here, again half here, and again half here, and so on. So that this is supposed to be 5,600 years. Draw the expected graph. Because this is first order, even if you go with 5 grams, so if this is 5 gram, then the 2.5, then 1.25, 0.625, the orange one, it is still the same. Time needed to reduce 5 grams to 0.625. Let me show you a single one is again clearer. See, this orange one is the second answer. 5, 2.5 is 1.25, 0.625. Then how many? 1, 2, 3. So that 5,600 into 3 is 16,800 years. See, we are again going back to this theory. Now they want to know these factors influencing the rate of a chemical reaction. I'm just writing this, right? Concentration of pressure, temperature, physical state, or contact surface area, physical state or contact surface area, catalyst, intensity of light and radiation, charge or current, nature of solvent, What are the basic requirements? That is, they're asking this collision theory. Let's write or check your answer. Reactant molecules should collide coming into contact. Reactant molecules should collide coming into contact. Reactant molecules should collide coming into contact. Next one. Collision should occur with proper orientation. Collisions should occur with proper orientation. Collisions should occur with proper orientation. Kinetic energy of reactant molecules. Kinetic energy of reactant molecules should be equal or higher. Kinetic energy of reactant molecules should be equal or higher than activation energy. They want us to show this Boltzmann curve, showing that T2 is greater than T1 with two different temperatures. T2 is greater than T1. So T1 is supposed to have this higher number of molecules. T2 is supposed to have higher number of molecules which are having the higher kinetic energy. If you go with this side, this part is greater comparing to this blue, this little thingy. When the temperature increasing, kinetic energy is increasing. Okay, 1 mark for molecular fraction, 1 mark for kinetic energy, 1 mark for this orange color curve with the shape, 1 mark for this pink color curve, and another 1 mark, see, crossing this. You have to cross them. You cannot draw like this. That's why I'm showing marks here. You guys need to maintain the shape starting from 0. Okay. Part 2. Consider the reaction and explain the following A and B. A mixture of H2 and O2 is stable at room temperature. However, mixture reacts rapidly when small amount of platinum is added. That's a catalyst, that is decreasing the activation energy. Then they are asking us to explain the action of activation catalyst. How does it happen? That's right. Activation energy of above reaction is very high. Activation energy of above reaction is very high. At room temperature, since temperature is less, molecules which exceed activation energy is very low. Therefore, effective collisions are low. Keywords. Platinum acts as a catalyst. It lowers the activation energy of above reaction. It lowers the activation energy of the above reaction through an alternative mechanism with less activation energy. Through an alternative mechanism with less activation energy. It lowers the activation energy of above reaction through an alternative mechanism with low activation energy. It increases molecular fraction. Which has energy equal or higher than activation energy. It increases effective collisions. Hence, mixture reacts rapidly. Also, that mixture reacts rapidly. B. This reaction is often accompanied by an explosion. What is the reason? Exothermic, so you cannot control. That is the reason. Let's write. This can be a chain reaction. Another explanation. Can be a chain reaction. Once a catalyst added, reaction occurs uncontrollably. Once a catalyst added, reaction occurs uncontrollably. Full stop. Since it increases reaction rate, this can emit high energy instantly. Since reaction is exothermic. One more sentence. Since reaction cannot be controlled, explosion can occur. Explosion can occur. Since reaction cannot be controlled, explosion can occur. D. This part is related to an experiment for the determination of order of the reaction between thiosulfate and hydrochloric And this is the reaction. I guess you know how to write this reaction from theory of inorganic as well. Describe how a measure of a rate of a reaction that we measure just to time taken to disappear the cross by making constant amount of sulfur. That is the method. That's right. Here, the time taken to form constant amount of sulfur. Here, the time taken to form constant amount of sulfur is measured. Constant amount of sulfur is measured. Next point. Draw a pale cross. Draw a pale cross using a black pen. Pale black pen. Draw a pale cross using a black pen on a white paper. On a white paper. Next point. Place. Next point. Place Na2H2O3 aqueous solution on it. Sodium thiosulfate aqueous solution on it. Next point. Start the stopwatch. Start the stopwatch when addition of HCl aqueous to it. When addition of HCl aqueous to it. Measure the time taken to disappear cross. Measure the time taken to disappear cross. Okay, lots of stuff are asking, are explaining of this next one. Okay, it sounds like a calculation. They are given this acidified Fe3 plus Ki and sodium thiosulfate. So the same reaction, exactly the same reaction they are doing here. Anybody needs me to explain the experimental part? Manu? Okay, so again the same experiment they are doing. Then they are asking why is the same amount of sodium thiosulfate is using. Okay, what we are doing is we are mixing this I minus with thiosulfate. Sorry. Fe3 plus, what is the main reaction here? Main reaction is between Fe3 plus and I minus. Yeah, Fe3 plus and I minus. So the main reaction is, you guys, I have forgotten, Fe3 plus and I minus. This is releasing what? I2. How do we measure I2? With starch. Once we add starch, within a second, it gives the blue color. So we cannot measure the time. So to delay that, we added sodium thiosulfate to react with I2. So once this sodium thiosulfate reacts with I2, this reaction is faster. So the next drop of I2 coming from this reaction is reacting with starch to give the blue color. Clear that? Okay, now they are asking, they were done this experiment in 3 different ways. Ki and all the other solutions, sodium thiosulfate, all the other, Fe3 plus and all the other. But the first question asking, same amount of sodium thiosulfate that we need to give this, to get this same amount of I2. Let's write that. Reaction between I2 and starch is rapid. Reaction between I2 and starch is rapid. Therefore, we add H2O3 2 minus aqueous. H2O3 2 minus aqueous. Comma, to delay the reaction. To delay the reaction. By adding same amount of H2O3 2 minus, by adding same amount of thiosulfate, comma, constant amount of I2 can be removed. Constant amount of I2 can be removed from the medium to give equal experimental condition. Therefore, it is possible to measure time taken to form. Constant amount of I2. Constant amount of I2. Role of starch is asking. Let's write. Starch acts as an indicator. To detect I2 formed. After all sodium thiosulfate consumed. Next point. Starch gives a blue coloration. With first I2. Comma, after all H2O3 minus. Finish in the medium. Last point. Therefore, the starch acts as the indicator. To get a clear observation. Okay. First set, Ki and everything. Okay. Everything mean that thiosulfate with H plus, you know, this reaction. And also Fe3 plus and thiosulfate together, they can react again. Second one is sodium thiosulfate, that is extra something. Main reaction is going between these two, so it is reacting. So the correct or suitable one is the C. So let's try it for A. When did you do this at the class? Yes or no? No. So U1 is not filled. I think I've done this earlier, but now I am skipping that. So repeating, nothing to repeat. Okay, A not suitable. Let's write. Reaction between H plus and H2O3 minus starts. Reaction between H plus and H2O3 minus starts before measuring time. Therefore, thiosulfate moles varies. B, not suitable. Let's write the reason. Before stopwatch starts, the main reaction starts between Fe3 plus and Ki. Fe3 plus and Ki. Between Fe3 plus and Ki. C, suitable. C, suitable. Okay, time taken for color change to increase. What would you do? Let's write. Increase the concentration or volume of aqueous sodium thiosulfate. Increase the concentration or volume of aqueous sodium thiosulfate. Next one. Decrease the concentration of Fe3 plus and Ki. To decrease I2. Decrease the concentration of Fe3 plus and Ki. Next one. Decrease the temperature of the medium. That is another factor you can write. Decrease the temperature of the medium. Moving to question number 5. Okay. Part of this is explaining how we can separate this after hydrolysis, this formed carboxylic acid. Just try to memorize this as a little theory because this part we never done in theory. The ester, this is a crystalline solid. R1, R2 are hydrocarbon chains. This ester undergoes hydrolysis to give following equilibrium. The statements given below refer to a procedure for the hydrolysis of the ester. Fill in the blanks in the statements using only suitable words, phrases selected from the list given below. The same word phrase may be used more than once. Okay, they are given these words: activation energy, boiling point, carboxylic acid, catalyst, concentration, contact, decreases, density, equilibrium, increases, left or right may be the equilibrium point, mixing, organic compounds, break, right, slowly, sodium salt, solid, yield. Some sort of insight comes even when you are reading those keywords, even you have done this earlier, that's why I have read that. The ester is ground to fine powder. Why is that? We are making anything fine to increase the contact surface area. Okay. Grinding increases the surface area of the solid. This leads to an increase in the contact between reactants, increases and contact. The rate of hydrolysis can be increases by using acid or bases. Hydrolysis by water alone occurs. Yeah, hydrolysis with water mean we are not adding any catalyst. So it is slow. Slowly due to the high what? Catalyst again connecting to activation energy of the reaction. Acid and bases are catalysts. They catalyze the reaction. Hello? දෙදස් විසි හතර සිංහලද ඉංග්‍රීසිද? ඔව් සිංහල මීඩියම් ක්ලාස් එක තියෙන්නේ සිකුරාදා උදේ 8:30 12:30. නෑ දෝනි එකටම දැන් හැමෝටම මම තියරි කවර් කරලා ඉවරයි. දැන් යන්නේ අර මේ ක්ලාසිෆයිඩ් පේපර්ස් යන්නේ ඒකක විදියට තියෙන. ඒකේ චාලක යන්නේ දැන් ඊට පස්සේ ලබන සතිය විතර පටන් ගන්නවා සම්පූර්ණතාවය. ඔයාලට WhatsApp message එකක් දානවද? ඔයාගේ විස්තර පොඩ්ඩක් ලියලා දාන්න. දූමට කතා කරන්න 6න් පස්සේ මම දැන් ක්ලාස් එකක ඉන්නේ. එයාට ඩිස්ටර්බ් නේ ඒක නිසා මේ ඔයා මට 6න් පස්සේ කතා කරන්න මම ඔයාලට විස්තර ටික කියන්නම්. මේ වීක් එකේ එන්න එපා රත්නපුරේට ගංගාතුර කියලා දන්නවනේ. හරි ඕකේ මට කතා කරන්නකෝ. ඕකේ. මම කතා කරාට බබා වගේ මුදුන මේක කරා. රිවිෂන් එක. හරි කියන්න දෙන්න. දෙමෝපියන්ගේ සල්ලි කන ඕගොල්ලෝ කරන්නේ නැහැ නේද? මොකක් කරන්නේ පානේ හැම හරි අමාරුයි යන්නේ අර සීරීස් එක ගොන් ළමින්ට මම ගන්න මහා ගොඩක් ඉඳන් කරා ඒක කතා කළා වැඩක් නැහැ. I'm so worrying about not about these kids but about their parents as well. Okay, so going slowly because activation energy is high because they need catalyst. Aqueous sodium hydroxide is more suitable than aqueous HCl. Memorize this as theory. Why? For the above hydrolysis, acid hydrolysis given an equilibrium mixture. So that is a we don't want equilibrium systems because we cannot get exact product because it's always going back and forth, back and forth. So some reactant, some product, some reactant, some product. So we have to manipulate the reaction to get products. So we don't want the equilibrium situation. To get products is not good with equilibrium. Mixture of products and reactants. Hence, the amount of products obtained is limited by the equilibrium concentrations. When base is used, the carboxylic acid formed on hydrolysis is removed from the equilibrium mixture as the sodium salt. The equilibrium is thus pushed to the right and the yield is increasing. Okay, what is happening there? This is the acidic condition. If you have a base, let's say sodium hydroxide, this is become ONA. This is water soluble. So this is get away from this mixture. This is become more water soluble. So reaction is moving more and more to give this back. So that you can, you cannot get this carboxylic acid, but very easily reaction goes to forward when you are converting it to sodium salt of carboxylic acid. So reaction go to right, yielding is increasing. The powdered ester is stirred with disodium hydroxide and heated to 60 to complete the hydrolysis. Stirring help. Why we are stirring? We are always stirring whatever it is, even at laboratory level, school laboratory level. Whenever we are stirring, mean more mixing. By mixing, what is happening? These reactant molecules are coming in contact better and more. Contact between reactants and heating increases the rate of a reaction. After complete the hydrolysis, now they explain why we are doing in basic medium, then why we are stirring, then they are explaining how we can separate this. After complete hydrolysis, when excess sodium chloride is dissolved in the reaction mixture, a white solid separates and rises to the top. When we are adding excess sodium chloride, it increases what? See, dissolving sodium chloride increases the concentration of ions in the solution or the density increasing. Under these conditions, the less soluble sodium salt of the carboxylic acid separates. As the dissolved sodium chloride also increases the density of the solution, the solid rises to the top. So the density of the mixture is increasing. So the low density sodium salt of carboxylic acid is coming to the top. So it's floating, so we can separate it. Not only for this hydrolysis, they are also showing how we can separate. Just memorize this little sentence, right? Paragraph. Any question? Okay, either MCQs or structured essay or essay, this method is exactly the same. Okay, so they are given this time 3 reactants and they are given these concentrations. Then we need initial rate. Remember this time in 2015, 2014 and 2015 are most challenging 2 years so far. So far the hardest. Like 2019 is the hardest. A pass given at 68 marks. 2018 chemistry, 19 chemistry is really harder. That's harder because the style is so different. you are practicing to this style for chemistry. All of a sudden, they are giving, let's say, the England style, or maybe they are giving the India style, changing the marking scheme. So you cannot get marks. That's what happened in 2019. Only that, they've changed all these physics board then. Anyway, so this time, we need to calculate the initial rate. They were not given that, but they were given initial A concentration difference and the time difference for each of these concentration. So concentration difference divided by time difference is the rate. So that each time we can calculate the rate. So we have 4 different values. Then, okay, that part you can sort out easily. Then I'm going to analyze, just go this way, even for MCQs I told you guys. Okay, I'm going to find for A, to get A is supposed to be different. B is supposed to be same, C is supposed to be same. So A between 1 and 2, just go with this sort of a little short note. To B is supposed to be different, A same, C same. So between 2 and 3, I'm going to find B. C, A and C. C is supposed to be different, but C, these two are same. And also these two A are same. So from 4 and 1, I'm going to find C. Knowing everything, and then since they were given this reaction, I'm going to write rate expression to this one as this. Can I do this? I can do this. Then I'm writing 4 different equations for these 3. I'm writing just simultaneously here. Then using 2 and 1, 3 and 2, 4 and 1. So with respect to A, it's 1. B, it's 1. C, it's 2. Then rate expression is this. But you had to write all these to get full marks. Understood? It is a must to write all these to get full marks. Here they were not expecting this part. Even if you have written only the answer marks were awarded only for these 4. Only for these 4. Not for the method. Done. Just show this as well. This is why we are taking this way. Okay. Then, okay. Just copy these 4. I mean, check your answers. If you want, you can copy these answers. Go with concentrations. Did I write concentrations in Sinhala? Concentration, I mean this units. I don't know whether it's here. Let's see. Concentration units. Yeah, I have written, I think I have forgotten that. So that I have written this concentration units like M. It is a must that you are at least going with moles per cubic decimeter, that M. Overall order, then K. I'm going to go with the first equation. Now I know the order. I'm going to substitute, only unknown is K. So you can get K 0.5 decimeter to the power 9 moles per to the power minus 3. Okay. In the above B experiment, the concentration of A changes with time t according to the following equation. A naught is the initial concentration. Show the half-life of the reaction is given by this. And calculate half-life using this above data. Okay, I'm going to go with the Sinhala one again. It's more clear, I guess. Yeah. This is the same one. 0.3, yeah. Did we miss a part? Yeah, we missed a part. Oh yeah, we missed a part. Sorry for that. But before that, we calculated K, then B1. In B1, in another experiment, if the concentration of A and B and C show that rate expression for the reaction can be given by this. So they are implying if this is a rate expression, it simply means this is only inclusive to the rate expression. It simply means with respect to these two, it's supposed to be some sort of a constant that we are adding all those constant into this constant. So K constant, B constant, C squared constant. Only with that we can say this is a new rate expression. Clear that? So that let's write with respect to A, concentrations of B and C are really high. With respect to A, concentrations of B and C are extremely high. Assuming B and C concentrations are constant. Assuming B and C concentrations are constant. Okay, 2017 A-level MCQ 38, right there. This is 15. So they were adding it again back to 2017. Here they are giving us a hint. These concentrations are constant. What is the hint? What's the hint? Hint is this. We cannot go to this. Not taking BCR constant. Okay. So they are giving that. So making, then copy here, copy up to here. Okay, that is the assumption. Actually, we have written that already, but we'll write it again. Let's write. Show this. Show this. Concentration of B and concentration of C is extremely greater than A. Therefore, when compare concentration of A, therefore, when compare concentration of A, changing of concentrations of B and C are negligible. Changing of concentrations of B and C are negligible. Okay, so this one they were given, this equation they were given. In that equation, what is this? This is the initial concentration. So initial concentration is the initial concentration. After time t, if you measure the concentration, that is concentration after time t. But that's not the initial concentration. But the concentration after time t is changing with time. If they were talking about t half, this is again not changing. This is the initial concentration. But this is become the concentration after time t. So this is the concentration of t half. What do you know about the t half? T half is become the initial concentration divided by 2. Clear that? Okay, so I'm just writing the given equation. Then T equals T half, then A become A divided by 2. Half-life is the time taken to concentration to be half. So I'm just writing same this. Then instead of this A, I'm writing A naught divided by 2. Then this K prime T become T half. This T become T half. 2.303 log. A naught is not changing, so I'm writing exactly the same way. Then minus K prime T half become plus K prime T half. Then this part I'm bringing to this side. Then this is full A naught, this is half. How much remaining? This is cancelling off to this one, on the plus part is remaining. Clear? Normal calculation. Just ask me if calculation is not clear. So then K prime T half is this. Then 2.303 log 2 equals 3010. That is this. Then this is a T half. And then K prime equals to this. See, K prime equals to this. Then I'm using K, B naught and C naught squared to calculate K prime. And to that, then K prime equals to this. Then to that, if you substitute that here, K prime to here, then you can calculate T half. Who got this answer? Come on. Every year, a couple of students are taking these answers. Whenever I'm taking the phone to do some sort of something, some errand, I'm taking the phone to my hand. But each time there are lots of WhatsApp messages. So I forget, then I keep the phone back after attending to WhatsApp. Then, I didn't do what I wanted to do. Then I'm taking the phone back. Tute, stop nibbling your nails. You're doing that, I guess. Are you nervous or something? Are you having the habit of that, I guess? Show me your nails. Come on. Usually you do that. When you're nervous, when exams are getting closer, usually. One of my friend is there, like, okay, her nails are like this. Our finger is here, our nails are like this, I guess. Let's say this is the skin of us. These our nails are like this. But her nails are like this. She doesn't let her just to get, not to growing, like you can grow like this. But this is fixing to the muscle. I don't know how you can do that. Stop. Okay. Could you do the last one? This one. What is this condition? Zero order. This is C, concentration of A decreases with time, but constant. That is for zero order. Then you can get 2 different points to get this. K. Okay. Rate of reduction of A. You can get any of these. They were given marks for both. Any of these. Okay, determine value of A. Let's write. The given graph is a straight line. The given graph is a straight line with a constant negative gradient. With a constant negative gradient. This kind of a graph can be obtained. This kind of a graph can be obtained for zero order reactions. For zero order reactions. See, that is the answer. Also, m equals dA over dt equals k constant equals rate. M equals dA over dt equals k equals rate. So that A equals 0. Is that all? No. Then they want us to calculate the rate constant K. Rate constant K. Okay, I'm going with these 2 points. Just show these points on your graph. I'm going with this 0.004 and 1500, 1 point. Then my second point, 0.002, and then this 2000, these 2 points. What are the points you have taken? I have taken points that which are easy to divide. Okay. So now we know since zero order, a to the power 0, so that r equals k a to the power 0. Since a is 0, r equals to k, but also r equals this. And so that we can write minus dA over dt equals k, this. Then I'm going to go with dA and dt. Just simplify. K equals 4 into 10 to the power minus 6 moles per cubic decimeter. Enemy. Well done. Baba, what happened to you? You didn't try this? After that, you didn't try? You tried. You didn't try. You didn't have time. Okay. Anyway, you didn't try. Yeah, that's my concern. If you tried, if you couldn't get the answer, then I'm worrying. If you didn't try anyway, that's okay, because I know if you try, you're supposed to get these answers. Calculate the pressure in the container when half the initial amount A gas has decomposed, assuming that the volume of the catalyst can be negligible. Okay, PV equals nRT. To find pressure, see the same thing, tell me that we did that MCQ question. We can find the pressure using this, but to that, then we need number of moles. To get number of moles, we have to go with this equilibrium part. Initial mole 0.01, 50% dissociation, that is 0.5. Then total become 0.01 into 0.5, that is 0.005. 1:1:1. Here the remaining becomes 0.01 minus 0.005, 0.005. These two remaining this way. Then the total number of mole equals this one, and this one. 1.5 into 10 to the power minus 2. Then let's go with this. Here again, I'm writing number of moles, R, temperature, volume, 2 cubic meters. Then to do the substitution, get the pressure. Here my simplification for this. Finish. Okay, I was waiting, you guys. Done. Okay. Okay. In the presence of a solid catalyst, the gas X decomposes according to this chemical reaction. I'm going with the Sinhala one again. So they are using these two different conditions. I have drawn them here. That's why I'm going to Sinhala one. Rate R naught, 1 mole of X, V naught, and here rate 0.25 R naught, 0.5 mole, 2 V naught. So first they want us to go with this rate, R naught equals Kx to the power B, but X they were given as 1 mole, volume is V naught. So to get this X concentration, I'm using those two. So this is the answer they are expecting. Concentration equals number of moles divided by volume. And then 50%, once the 50% using, remaining is become again 0.5 of 1. Then volume is 2 V naught. Then this 0.5 divided by 2 V naught is this. Then this is a new concentration. Okay, so the new rate 0.25 R naught K, but then X equals to this 0.5 divided by 2 V naught to the power B. Now I have 1 and 2, same B, same V, same R. So the only unknown is B. So you can calculate B equals to 1 very easy. Copy this. Okay. Have you noticed that 2 hours already passed? I didn't notice that. Time goes really fast today. For me, I feel like. Okay, moving on to essay part. But still, let's get a little break. Okay, you too. Get this. Get this. Let's say 3-5. I'll be back on like 3:15. Thanks. She's so Okay, Manut, I don't have again this English medium questions with me. So let's go with Sinhala medium, okay? Moving on to essay, chemical kinetics. Little by little, I am bringing you to your goals and stick to the plan, okay? 5 more months to go. A gas, B gas, forward reaction, backward reaction, goes to 2AB. They want us to write the rate expression for forward and backward reactions. And when both reaction rates are equal, they want to write ratio for this, expression for this. And what factors encouraging forward reaction. Okay, this is directly theory, and do you guys know this kind of questions now they're asking after 2019, they're asking such simple questions directly from theory. Okay, this is reaction, this is minus. If order with respect to A, B, and AB are M, N, and Y respectively, we have to write that respectively. We have to write that because we are introducing this M, N, and Y. Then for forward reaction, this is the expression. For backward reaction, this is the expression. If these two are equal, if two rates are equal, we can equalize these two. So you can get this expression for KF by K. Okay, to increase reaction rate. That's right. Reaction is exothermic. Reaction is exothermic. When temperature of the system decreased, comma, reaction occurs to the direction, to increase the temperature, towards right, comma, forward, comma, according to Le Chatelier's principle. According to Le Chatelier's principle. By increasing A2 gas or B2 gas, comma, since reactant concentration is increasing, reaction favors to the direction, to decrease their concentrations. Therefore, equilibrium point shifts towards right. According to Le Chatelier's principle. By decreasing AB gas, products can be removed, comma, therefore, to increase products, reaction favors to forward direction. Last point. Since catalyst decrease, activation energy of both forward and backward reactions, comma, reaction rate of both forward and backward reactions are increased. Reaction rate of both forward and backward reactions are increased. Therefore, time taken to reach equilibrium decreases. Time taken to reach equilibrium decreases. Time taken to reach equilibrium decreases. Okay, that's all for first question. Moving to question number 2, ionometric method. We did this between I minus and Fe3 plus for theory, and we did that one here today. But they were given I minus reaction with H2O2 here, H2O2. Okay. So the concentrations and given, and also they say starch is using here. First question. They want us to write the balanced chemical equation and then find N. They say with respect to H2O2, order equals to N. So H2O2 supposed to be different, and Ki supposed to be equal. So I'm going to go with the first and second one to that. It's not necessary to go on with all these half reactions, not necessary. But I'm just writing for your practice, not necessary. Either they are expecting balanced ionic equation or balanced chemical equation is more than enough. So we have the equation to this concentration, but here they were given volumes. We cannot directly go with that, so we have to show that concentration and volume are equivalent to each other. So that I'm going to start from here. R is proportional to H2O2 and O2 to the power N. But when the total volume is constant, we can say that the concentration is proportional to volume. So instead of concentration, we can write volume to the power N. And also, R we can get again formed I2 and the time for that. But formed I2 always we are using same thiosulfate. Constant thiosulfate is a constant. So K1 divided by T. Then this is X and this is Y. Equalize X and Y. So you can end up here. So that you have two different conditions, 2 times and 2 concentrations. This actually is the rate, okay? Same N, same K cancelling off. So you can get N value. Okay. Start copying from here. Part C, explain that why it takes time to appear this blue color. Okay, copy these 3. Slow, fast. Okay, let's write. A very low I2 concentration. A very low, sorry, at very low I2 concentration, at very low I2 concentration, within bracket 1 into 10 to the power minus 5 moles per cubic decimeter. 1 into 10 to the power minus 5 moles per cubic decimeter. Starch turns blue. Starch turns blue. Next point, to delay the time taken, to delay the time taken to give blue color, to delay the time taken to give blue color, comma, Na2H2O3, sodium thiosulfate is added. Sodium thiosulfate is added. To give some experimental conditions, to give same experimental conditions, to give same experimental conditions, same amount of sodium thiosulfate, is added, Therefore, blue color does not appear. Therefore, blue color does not appear. Blue color does not appear instantly, and takes some time until thiosulfate H2O3 2 minus finish. Until thiosulfate finish. Okay, in part D, they are considering this green, that's why I have made it green. This third mixture, they take, when the time is 21 seconds, at this time, they want us to give this H2O2 concentration as a fraction with respect to initial concentration. Okay. So H2O2, H2O3 2 minus, ratio is 1:2. At that thiosulfate 0.001 10 cubic centimeter we're using. At 21 seconds, so 0.001 10 cubic centimeter, where that is using. Did you guys do this? No, really? Okay, are you guys understanding this? Just read the question ahead of me. Then, this is the thiosulfate using. That is 0.5 into 10 into the minus 3. That is 5 into 10 to the minus 5. This is 2 actually. So that, divide that by 2, 1. So that is H2O2. So this is the reacted H2O2. Initial H2O2, if you go with the table again, that's 3 cubic centimeter, 0.1 into 3 into 10 to the minus 3, that is 3 into 10 to the minus 4. Then get the difference between total and reacted, and remaining is this. Then they are asking initial to remaining. This is the initial and this is the remaining, but now in same volume. So it is this. We don't want this volume. We don't want the volume to substitute. Okay, let's write. Na2H2O3 finished. Sodium thiosulfate finished in 21 seconds. Therefore, I2 reacted. Double arrow. From that, H2O2 reacted. I2 reacted, from that H2O2 reacted. Can find. Na2H2O3 is the limiting factor. Na2H2O3 is the limiting factor. That's why we can use sodium thiosulfate to find H2O2. Okay, copy this. 10 to the power minus 3 here, not 2, okay? 3. Just for your knowledge, chemical kinetics is supposed to consider as a highly scoring unit, Manu. Whenever there is a question, students are getting maximum marks. Those units are called highly scoring, unit 4, 5, 11, and 13. Short physical units. There is this fixed method, you can get answers very easily. Okay, then they are giving another data saying that at 310 in third mixture, time taken is 15. See, it is just the same third mixture. So this is at 300 Kelvin. So 310, see time taken is less mean. Time for blue color decreases, mean reaction increases, rate is increasing. Collisions per unit time increasing. Number of moles exceeding activation energy is increasing. Collisions with proper orientation increasing. Number of effective collisions rate increasing. And fraction of molecule exceeding activation energy also increasing. Okay, I want you to copy and show everything here. I'll highlight all this. Time for blue color decreases, and this collision frequency, collisions per unit time increases. Then also show this graph as well. Okay, very first test you came to the class, you never had this phlegmy condition. Why it is persisting now? Yeah, did you visit a doctor? Is your mom and dad concerned about this? This longer? Yeah, you're going to eat a lot of proteins, vitamin B, black chocolate, dark chocolate. Okay, ask your mom to supply those, okay? Lots of fish. You guys have to be really, really healthy for final exam because you are so much away from the exam. If you get not well for now, what's going to happen at closer to exam? Be really healthy. Seriously. Consider food as part for good results. Then you can eat more. Consider eating food gives you marks. Then you would feel like finish everything. But that's true. Indirectly, that's true. Brain functions are deteriorating if you do not eat enough. Factors affecting rate of a chemical reaction. An illustration of one factor just once I'm going to do this. Where is this answer? I think I've missed this answer. Yeah. But number 4 is there, number 3 is not there. Let me get this. Okay, let's write answer for number 3. Concentration of pressure, temperature, physical state or contact surface area, catalyst, nature of solvent, light intensity and radiation, charge or current, Okay, illustration is exactly what we did for theory. Okay, just going to show everything here. Show this. Show all this. Moving to question number 4. Okay. Concentration 0.16. Sodium thiosulfate you are just keeping here. Then you are adding HCl to that. And 0.16 sodium thiosulfate, 3 mHCl. Keeping acid concentration constant. So you can write this. Keeping sodium thiosulfate constant, you can write this. Then they want us to find this M and N. So if you go with this, HCl is constant, so you can find with respect to thiosulfate. Okay, if you go with all these four, thiosulfate is constant. Changing HCl rate is almost same. So N supposed to equals to 0. Shall you write those? Okay. See, V total is 30, that's constant. Concentration is proportional to volume. So HCl concentration is VHCl. And thiosulfate concentration become V thiosulfate. So you can write these two. And at the same time, amount of sulfur formed is constant. So that you can write this and this. This just to get this two different equations. Or otherwise, using this value-added method, you can get the answer as well. To find n, you are just saying this logically, n equals to 0. Start copying from here. I'm going to have a full free week again. No classes in Ratnapura. Flood sometimes is a blessing. After your class, when will be the next class? Yeah, next Saturday. There are two different methods. මංජල මම WhatsApp එකක් දැම්ම last page එක දාලා එතනින් එහා questions ටික මේ photocopy එක ඕනි. ආ 11 නෑ නෑ. අර 11 මම කිව්වේ MCQ ටික දෙන්න කියලා. ඒක මම අන්තිම ප්‍රශ්නාංකයට එනකම් අන්තිම මග ළඟ තියෙන page එක දැම්මා. ඒ page එක තියෙනවා. එතනින් එහා pages ටික photocopy කරලා ඕනි. Simultaneous equation method or value added method, value substitution method. Very recently, a kid has died playing with a phone. She's like he or she, I don't remember. Like 3 years old, playing with the phone that joined connecting to this wire. Even you can touch this, no current. I don't know how she has died. I'm scared to touch, but accidentally I'll keep touching this. But nothing happened. Maybe a power surge or something. High voltage came like. Okay, let's write to find n. To find n. In reactions, 5, 6, and 7. 5, 6, and 7. VS2O32 minus is constant. Thiosulfate volume is constant. VHCl vary. VHCl vary. But time taken is nearly constant. But time taken is nearly constant. Even reactant concentrations changed. Even reactant concentrations changed, comma, if time taken to get products, if time taken to get products are constant, comma, the reaction is zero order. The reaction is zero order. The reaction is zero order. So show that n equals to 0, n equals to 0. The same sort of a question they are asking again. Go with this third one. Okay, in modern chemistry, they are not asking this sort of a questions now, but so that concentrate a little with that. Okay, so thiosulfate 0.16 into 20. They are asking how much fraction is working at that time. Okay, so this is the reaction. They were given the concentration of sulfur here. So that I need the stoichiometry between sodium thiosulfate and sulfur. 1:1. So this is the sulfur and the V total is 30. Sulfur amount is 0.01. You can calculate sulfur amount. The number of moles of sulfur equals to number of moles of thiosulfate with the stoichiometry equals to 1:1. So that this is the used amount, but 20 cubic centimeter we're using in the third one. So this is the total amount. This is the total. Then get the difference of those two. Fraction equals n reactor divided by n total. So you can get the answer very easily. Even it's really all, it's a good question. Like you have a little to think. So I'm going to skip same answer questions, okay? If the answer is same, I'm going to skip those questions. Moving on. Okay, just copy the answer. Therefore, fraction reacted. N reactor divide N total. Okay, part C. Higher temperature, time is increasing, don't write. Exactly same thing we have written. So just write this one. Q2E. We have written everything there. Exactly same everything. So I'm not going to do that. Okay, collision theory. For the part 5, they're asking the collision theory. So requirements asking, requirements are the collision theory. Let's write. X2 gas and Y2 gas molecules. X2 gas and Y2 gas molecules should collide coming into contact. Should collide coming into contact. Coming into contact. X2 gas and Y2 gas molecules. X2 gas and Y2 gas molecules should collide with proper orientation. Should collide with proper orientation. Should collide with proper orientation. Either this way or this way. So that's very easily you can get from products because they are giving 2xy. So x and y supposed to join this way. Say, see, breaking these bonds. Okay, copy these two. That's you supposed to think how to do this, okay? X2 gas and Y2 gas molecules should have a kinetic energy. S2 gas and Y2 gas molecules should have a kinetic energy which is equal or higher than activation energy, which is equal or higher than activation energy, which is equal or higher than activation energy. Okay, just consider this equation. Keeping the M concentration constant, L is reacting. So they want us to write this rate expression between the rate of reaction with L concentration. Just a normal. Okay, this they were not given. And K they were not given. Why they were not given? So that we are introducing them. Copy this. R reaction rate, Y order with respect to L, K is the rate constant. When you're writing, you have to introduce new terms you are using. R reaction rate, Y order with respect to L, K rate constant. X goes to Y. Temperature is constant. You don't know the stoichiometry. Initial concentration. This is the second concentration, and then the rate is 1/5 of the initial. The rate is half. Then they are asking the concentration when the rate becomes 1/5. So I'm going to go with this simultaneous equation method. So when the rate is R, they were given the concentration. When the rate is half, then they were given the concentration. Okay, so from that, this is to the power x, only x, okay? One reactant. So you can find x with that, x equals to 2. Whenever it comes like this, what you're supposed to do is just multiply this by this and get this value here. So 1 over 2, 2 over 1. That is 1.9, that is almost 2. Let's say that this is x equals to 3, then if this is 3, then you have to multiply, let's say the value is, okay, when it comes to later, I'll explain that again. For now, just remember, to get this kind of answer, just multiply this one with another, then it's supposed to be closer to this. Okay. Then you can calculate x here. Then the second time they are asking 1/5. Now you have everything other than x. Then just calculate the x. Okay. Start copying from here. If you guys have done these questions at home, I thought we would be able to finish in it, almost finish in it. 11. Okay, this again, not with H2 and Cl2, they were asked that earlier, but I'm going to write this. This time they're asking with HI, that is H2 and I2 together. Initially not happening, but once they have added this platinum, it's dissociating. Let's write that. Part C1. Activation energy is the energy barrier for any reaction. Activation energy is the energy barrier for any reaction. Energy barrier for any reaction. At room temperature, comma, it does not provide activation energy. Activation energy. When heated, kinetic energy of molecules exceeds activation energy. When heated, kinetic energy of molecules exceed activation energy. Therefore, collisions with proper orientation increases. Therefore, collisions with proper orientation increases. Therefore, collisions with proper orientation increases. Therefore, reaction occurs easily. Therefore, reaction occurs easily and HI decomposes. And HI decomposes. Okay, that's when you heat. Okay, next one is with platinum. Let's write part 2. Platinum is a heterogeneous catalyst. Platinum is a heterogeneous catalyst for above reaction. For above reaction. Platinum provides an alternative path for the reaction which has low activation energy. Therefore, number of molecules which exceed activation energy. Therefore, number of molecules which exceed activation energy, Manata, are you okay? At room temperature increases. At room temperature increases. Therefore, HI decomposes at room temperature. Therefore, HI decomposes at room temperature. Therefore, HI decomposes at room temperature. You're going to show this little thingy. This is a fraction of molecules and show that normal activation energy, number of molecules exceeding activation energy, this is EAC. When you have a catalyst, more molecules are exceeding activation energy. I show this. This is just EA. This is EA catalyst. Write this point. Since activation energy decreases by catalyst, molecules which exceeding activation energy increases. Molecules which exceeding activation energy increases. Okay, this is why I don't do this part for even for revision. Anyway, what is catalyst and catalytic properties? I know this is little like time consuming, but I want you guys to write this. I love to write like a directly theory note. Let's write. Substance 7.1. Substance which provide substance which provide an alternative pathway, substance which provide an alternative pathway with low activation energy, for a particular reaction, is a catalyst, Catalysts participate for the reaction. Just continue one paragraph. Catalysts participate for the reaction, but does not change chemical nature, comma, physical nature can be changed. Okay, if you have forgotten the properties or the characteristic, let's just write a little faster. Part 2. Number 1, increases reaction rate always. Number 2, does not change magnitude or sign of entropy. 3, does not change magnitude or sign of enthalpy. Number 4, does not change the Gibbs free energy. Number 4, does not change the Gibbs free energy, hence spontaneity, full stop. Number 5, does not change stoichiometry. Number 6, activation energy decreases. Number 7, Savi darling, I guess you're okay. Number 7, change the mechanism. Number 8, order of the reactants may change. Comma, since the mechanism is different. Number 9, rate constant can be changed. Number 10, does not change the chemical nature. Of catalyst, comma, but physical nature can be changed. Number 11, does not increase percentage yield. But decreases time taken to get the product. Number 12, it is characteristic for a given reaction. Last one, number 13, does not change the equilibrium constant. very first days when you guys are writing, you guys feel like, even we did this for inorganic, like we are writing very faster. But if you cannot maintain that speed, writing everything for the final exam is harder. Especially for biology, get this practice, okay? So in the presence of bases, H2O2 decomposing this way, we can show this rate expression as this. H2O to the power m. They want us to suggest a method to get this value of m. Do we need to write everything? Yeah. I cannot skip any of these because in this, okay, after 2019, some sort of a difference is there. Style is different. One of the students already came to this, before results came, she came to my this Ratnapura English medium class. She said her marks, that's not acceptable. She has taken like 25 MCQs. She was like, the format is totally different, so she couldn't understand that. There is no such thing, format is totally different, but something is different. A little difference is there, but you are doing starting from 2019, 20, 21, 2, 3. Yeah, you have 5 papers and prototypes and everything. You can get this idea. Still, these students reach 50 out of 50. She has something, I think she just said that. Anyway, in this new syllabus after 2019, they are directly asking such questions. There are questions that you have to do this kind of a little, like, you know, the arrangement, and then you have to give the answer, this experimental data. Then how you're going to do this calculation and so on. So let's get that practice little from here. I think that's the reason my students are reaching this almost 100, because I'm not skipping any of these questions. Okay. Then when I was like, Dhoni, did you do these past papers? She said, yes, ma'am, I did. Then I was like, how many questions, how many papers? She said she has done 15 papers. Okay. Then when we are doing classified, then I was like, we have to make questions in the path, because if you have done full papers, all the questions are there. Then she was like, no, ma'am, I only did MCQs. See, 15 full papers became MCQs. Then when I was doing MCQs, I was like, tell me what's wrong with you? Are you okay? Do you want to drink water or something? Are you on medication or something? Do you want to go and wash your face a little? Just have some water. Do you have water? You can drink some water. Then she said she has done MCQs. Then later she said she has done MCQs only for last 5 years. How poor her knowledge. Then after the class, I gave her this lecture. This is not enough. I don't know. She has gone to these individual classes. How much money she has wasted just to get, I don't know her results so far. Maybe a C pass with 25 marks, that's still not enough. Okay, we are getting this exact, precise practice. So let's write this. Arrange the experimental setup. See, you're supposed to think like this. Arrange the experimental setup according to below diagram. According to below diagram. According to below diagram. Fill test tubes according to below table. Fill test tubes according to below table. Fill test tubes according to below table. Okay. Next point. Measure time taken to collect. Measure time taken to collect unit volume of O2. Unit volume of O2. See, we did this experiment for what? This kind of experiment we did too, something else. Downwards displacement or the collection of this H2 gas with the reaction of magnesium and HCl in unit 4 to find what? To find molar mass of magnesium under unit 4. if you have remember. So the rubber band thing, can you remember that we did 10 cubic centimeter, then fill with water, then mark the rubber band level, then always we are measuring exactly same volume. Understood? So here, what is constant? Amount of O2 is constant. Copy this table and this diagram too, both diagram and table. In this class and my Ratnapura Sinhala medium and my Ratnapura English medium, there are a couple of promising students that I can bring you to island ranking, but still, you guys have to balance all these three subjects. Balance all these three subjects. Okay. See, just right there. Want to finish? Yeah, we total I have taken as 26. You can just with arbitrary, okay? Then let's write this. V total equals 26 cubic centimeter. Then add H2O2 and H2O. Add H2O2 and H2O according to step 1 to 5. According to step 1 to 5. Start the stopwatch. Start the stopwatch when addition of OH minus. When addition of OH minus. I'm not wasting time on explaining this theory. Copy this. Or otherwise, we can go with this value added method. Show this. Bless you. Okay, then this expression they were given. This expression they were given, then they were given two different conditions. If this expression given as a data, then they were given two different conditions. 1:1 to 1:2.2. Then they are giving this rate ratios 1:3.95. Then the second condition 3:1 to 1:4 to 1:0.59. So both these conditions are given. So you can go with when I'm not substituting 1:1. The first one 1:1 is A:8 is constant. So then y is different. For x, it's 1:1. So you can find y here. Then knowing x here, we can find y here. Sorry, knowing y here. Sorry, y equals to 2. Y equals to 2. Then you can find x here. Clear that? Moving to question number 9. Okay, that we did earlier, the factors affecting the reaction rate. That's under question number 3. This explain these methods. I'm not going to do that. What are the requirements for this collision theory? What is this Boltzmann distribution curve? And what are the important properties that you can understand from that? That's again, we did under question number 5. See, I'm not going to just see this, but you have everything in the theory. Do you want to copy this, Manu? Yeah, because this is exactly theory. You're just writing. You know how to write this one. Collision theory. Let's write this. B1. B1. Generally, we are writing this. B1. Number 1. Reactant molecules should collide. Reactant molecules should collide coming into contact. Reactant molecules should collide coming into contact. For Ratnapura students, if you want these answers, you can just pause the page and get the answer. Number 2, collision should take place with proper orientation. Collision should take place with proper orientation. Number 3, kinetic energy of molecules should be equal or higher than activation energy. Equal or higher than activation energy. Equal or higher than activation energy. I want to write this part, that's why I want to rewrite this. Let's write the normal sentence, normal point. Collisions which satisfy all 3 requirements. Collisions which satisfy all 3 requirements are called successive. / effective collisions. Effective collisions. 1 over 100,000. 1 over 100,000. Collisions become successive collisions. Collisions become successive collisions. Okay, I'm giving this knowledge of this Maxwell-Boltzmann distribution curve. Otherwise, this is theory, okay? Part 2. Graphical representation of rate distribution of molecules. Rate distribution of molecules is called Maxwell-Boltzmann curve. Maxwell-Boltzmann curve. Maxwell-Boltzmann curve. Copy this. Y-axis, number of molecules with certain speed or molecular fraction. Number of molecules with certain speed or molecular fraction. X-axis, speed or kinetic energy. Speed or kinetic energy. Let's write. The curve starts from the origin. The curve starts from the origin. It is not symmetric. It is not symmetric. And it spreads more towards right. And it spreads more towards right. To explain activation energy, and other factors affecting reaction rate, comma, this curve can be used. This curve can be used. This curve can be used. Okay. Question number 10. BX2 is dissociating this way. We can measure rate only with respect to BX2, which is the reactant. Releasing of this mixture of gas, releasing of 1 milliliter. They were taken the time and also the connection with time with the concentration. 2 times 2 concentration given. BX2 aqueous concentration, when the concentration is 0.045, they want us to calculate how much time to release this 1 milliliter. For that, we need the order first. Okay, so they were given 2 equations. B is proportional to concentration of BX2R. R also proportional to 1 over T because volume of gas liberated is constant. So I can add these 2 together to come up with this kind of equation, which is the main equation. So 62 time and 122 time. K is constant. So subjecting both these concentrations, only unknown is N. See, this is almost 1.9 is almost 2. Then I'm going to multiply this by itself again. Whether see it is giving this. See, we did this one before in question number 7b. Or you can go with log values. Don't go with log values, it's time consuming. N equals to 2. So then I'm making third equation because they want to go with the new concentration. Then they want to find the time, but this time this order is non-order. So that time is 15 seconds. Okay, then why reaction rate is increasing so badly when the temperature is increasing even a little? That we explained in question number these two. Okay, copy these two. Q4C, Q2E. Q4C, Q2E. Then write, due to these two reasons, kinetic energy and actuation energy, due to these two reasons and collisions, okay? Even with a slight increasement of temperature, even with a slight increasement of temperature, comma, reaction rate increases considerably. Reaction rate increases considerably. Reaction rate increases considerably. You have zinc and sodium hydroxide. How do you show? It's depending, the rate is depending on the surface area. So you're using the same condition. So using the same everything. Only difference is this time you are using 2 grams of zinc and these are just the pieces of zinc. That is the only difference. We did this kind of a question in 6A, but I'm going to do that. Then the next one is in between dichromate, potassium permanganate C2 minus. Only difference is the temperature. You are showing the equation. See, you are showing the equation and also observation and conclusion down there. I want you to copy these two fast. Both are here. Part 1 and 2, question number 11. Okay, memorizing is a little harder, this permanganate oxalic, but we did this for even for unit 3 for this balancing. So you guys need that knowledge. Then part B of question number 11. See, they were directly given the time, so you can go with the time, 1/t. And here, these two are same. These two are, different. These two are same. So you can find with respect to B here, then these two are different. These two are same. So with respect to C, you can find order there. And also they are given this one here again. So this 92 question is extremely easy one. Okay, as a data, they were given this. So I'm just gonna use that. They were given this as a data. And concentration is proportional to volume. Since the total volume is constant and it's 50. So that instead of concentrations, now I'm going with volume. At the same time, R is proportional to 1/t. Since solid D is also constant, so that I can end up here. So I'm writing with the first and second here to get X, with the support of third and fourth to get Y. And again, C. When you are getting this value here, you can go with this normal log calculation, or otherwise this number just multiply by the same number. See, you are getting this one. Or otherwise this one multiply again with this one and then multiply again with the same. Then if you are getting this one, then order is 3 and so on. That's easy. Okay. Oh, why? Okay. The last equation. And then the conclusion. Not only the last equation, you have to write this conclusion as well. Manu, come on. Okay, right answers. I'm skipping question number 12. That we did under question number 7.2, Q7.2. A collision theory we did earlier. Why this reaction rate increase in the presence of catalyst? So I'm going to do that. So we skipped this one we did earlier, question number 12, Q7.2. Then 13, first part, right? Q9B1. This 13 part 1, Q9B1. Let's write collision theory we did a couple of times. Let's write these two. This is again theory, but I want you to have this proper knowledge. If they ask this kind of a question for the marking scheme, you have to write everything. That's why I'm doing this. Let's write catalysts are substances. Catalysts are substances which increase reaction rate, by decreasing activation energy. By decreasing activation energy, comma, by finding an alternative pathway, by finding an alternative pathway for the reaction. By finding an alternative pathway for the reaction. Therefore, number of molecules with kinetic energy, equal or higher than activation energy increases. Equal or higher than activation energy increases. It increases number of effective collisions, it increases number of effective collisions, and therefore reaction rate increases. And therefore reaction rate increases. Copy this. With catalyst and without catalyst. Moving on to question number 14. Ethyl propionate. Ethyl propionate, they expect you to know this structure. I have the equation, I'll show it later. So is catalyzed by H2SO for this dissociation. How do you show it? They're asking that. Okay. Catalytic action. So they have a couple of questions with this part, MCQs sometimes in these modern papers. This is the ethyl, ethyl propionate. So you are getting these two. So I'm going to do 3 different iterations. Whatever the H2SO4 using here, only with that H2SO4, titrate with phenolphthalein. So V sodium hydroxide is V1. Then only the ester, titrate with phenolphthalein. So sodium hydroxide is V2. Without acid, there is this little ability of dissociation. Then you add ester and H2SO4. If this volume of sodium hydroxide is V3, this V1 minus V3 supposed to be greater than V2. Not equal. You would think it's equal. But it is greater because part is now acting as this, existing as this carboxylic acid. So the value is supposed to be greater. Clear that? Okay, copy this. If there is no this acid, this greater part is responsible to this acid because it's catalyzing. Okay, everything is given in this one. With respect to AM, with respect to B, it's N, they were given the data expression. To find A, I need A to be different. But see, these two are almost same. See, they are trying to track you like 1.2, 1.19, 1.2, 1.19, almost same. So from these two, I can find M, order with respect to A. These two are almost same. See, these two are same. But these two are different. These two are different. So with that, I'm going to find order with respect to B. Then later, they say Q is a constant. Who cares that? So just let it be. When the concentration is this, and they were given another concentration of A and B, at that time, they want us to find the rate with respect to Q. I mean, in terms of Q, in terms of Q. Okay, just leave the Q, it's all right, it doesn't matter. So Q is cancelling off here. See, Q is cancelling off. 1 and 3 to give M, 2 and 3 to give M. Then, so the fourth equation I'm generating, A concentration, B concentration given. So now we have calculated these two already. So, if you go with the first equation here, that one has 1 Q. So I'm dividing this one with the first equation. So Q is remaining here. In terms of Q, it is 72 Q. Knowing this 3 and this 2. Is that clear? Okay, easy questions, but I don't know, like, are you guys understanding? Okay, you guys have to read the question before, okay? Copy this. See, go with the unit, otherwise no marks. Next day, we definitely going to finish this unit. Then, where's this? To find this equilibrium revision. For Ratnapura students, I've given like 2 consecutive recordings. Then I promised that I wouldn't give you guys any more recordings. But this is a natural disaster. That's not my on my hand. Anyway, so only for this week. From next week on, we are again going with physically, okay? Just hang in, okay? Whatever you do, remember the way we did during this COVID time, always online. Luckily, they have fixed your date long ago. Hope that they would, let's hope that they wouldn't change the date. Moving up. Can I move up here? Remember, I keep saying, if you've done this ahead of me 3 more times, but if you've done after me, it depends on your confidence level. Until you feel the unit is yours, regardless how many times, you're going to do this continuously until you feel comfortable with that unit. So you guys are not going to any online classes. I think Ratnapura are doing this mistake. Because this Zara, she is a really talented student. She went all the time to this online class in Candy for Arendra. Somebody who done physics in Candy, I guess. Is he doing in Colombo too? How is his results? Oh, yeah. Anyway, so this girl got a B pass. So I want you guys to stop such classes because she's really talented. Normal student getting a B pass is okay. To very talented student is, I'm not accepting that. Part C, that collision theory again. We did that earlier. I'm not going to explain that. Part C, collision theory. Little more to go. Okay. In gaseous homogeneous catalysts, they want us to explain with an explanation. Let's write this. Homogeneous catalyst. Homogeneous catalyst. Let's start from this one. Okay. Homogeneous catalyst. Both catalysts and reactants are at same physical state. Both catalysts and reactants are at same physical state. Copy this. Refer MCQ 16. Refer MCQ 16. Okay, let's go with the example. Example, oxidation of SO2. Oxidation of SO2. Show this equation. NO gas is a catalyst, okay? Write here down there catalyst. Then write both NO and reactants are in both NO and reactants are in same gaseous physical state. Same gaseous physical state. NO participates for the reaction. NO participates for the reaction, comma, changes the reaction mechanism. Suji changes the reaction mechanism and regenerates. Changes the reaction mechanism and regenerates. Copy this. Suji. Please come, Suji. Okay, we're going to start from question number 15 next. Okay. And now you all have this equilibrium. I'm not sure that we most probably we would finish this one. Then you guys have to do a couple of equilibrium questions as well. Let's say maybe 50 questions, MCQs. Then remind me to send me that revision part. Okay. Okay. Bye. Take care. It's at night. Did you guys give the? Please, she's so I don't know. Okay. Again, I'm requesting because I'm worrying about these 23 results. 24 results, like there were a lot of, 22 results, there were a lot of students that followed my instructions for other two subjects. But 23 students, they have followed instructions only for chemistry. Don't let this happen to you. Okay, bye, take care everybody. It's at night. Ratnapura student, just hang in for one single day.